Django models are an incredibly powerful feature that is used within Django to store data. And we're going to be using them extensively this semester. They build on many of the concepts that you learned in MISY 330, and we're going to walk through the basic concepts today so that you can understand how to apply them in your databases and your web projects. We're going to talk about this a few times this semester, but the model view template approach to Django is incredibly powerful. The idea of a model is the idea of persistent data, which is usually a relational database. In your project, you'll have, for example, the db.sqlite 3 file, but it could be something like Postgres, it could be Oracle, it could be SQL Server. Anything can be used with Django. We're just going to try to keep it simple this semester. The view is the logic that selects what the user ultimately will see. Now, this is not the web page itself, but it's the logic, it's the Python code that determines what the user will ultimately see. And then the template, of course, is the web page itself. Now, we'll see later in the semester when we get to the template section, we will see how to actually use things like HTTP response as well as the render command to generate HTML files. But we haven't quite gotten there yet. But that is the part, the actual web page is the template. Now, one of the things I want you to notice is that each of these represent a different career or career path within a large organization. The model, for example, you'd be looking at a database administrator, for example, who has skills in relational databases and SQL. For a view, you'd be looking at a programmer, somebody who knows Python. And then for the template, you'd be looking at somebody like a web designer who knows HTML, CSS, Bootstrap, those types of things. These are all very, very different skill sets. In most organizations, they represent completely different people. And we'll make the point throughout the semester that this is one of the reasons Django is set up this way, because each of these different skills allows different people to work on a website without interfering with each other. So how do we specify a model? Well, in a Django application, the model is specified in the Models.py file. And in a subsequent video, I'll walk you through how to exactly do this. But an example might look like this. We create a class called house, all right? And house would, for example, might be a real estate database. And we import the models.model file, which gives us a lot of functionality. The library models.model. So for example, we might have an address, which would be a char field. Char field is characters. So it could be something like your address, the street you live on, 123 Main Street. The city, of course, is the city you live in, also a char field. The price is, of course, maybe the price of the house that it was sold for. That's an integer, so you could list a house at maybe $300,000. The image file, Django has a really powerful collection of field types. And what this allows you to do is upload an image, and Django will store the address and the name of the file that is associated with that particular house, along with the location to where it's going to be uploaded to. The date that it was posted, again, Django has built-in fields. The date field, it has a date field. It has a number of different fields. But you can even, for example, specify for the date field to automatically populate it with today's date. You can do that as well. And sold is simply maybe a Boolean field so that we can pull up all the houses that have not yet been sold, or maybe the houses that have been sold. So there's a lot of very cool features with this. As I said, the class becomes a table in the database. The char field it represents a character field. In this case, it would have a maximum length of 50. An integer field, of course, will be a whole number. As I mentioned to you, the image field allows you to store an image within your project, which is a really cool feature to be able to do that. It will automatically implement the functionality to allow you to do an upload to your project. A date field, of course, it has, in addition to date fields, it also have time date fields and time fields, and there's a variety of different pieces of functionality with dates and times. And of course, this allows us to choose whether the house was sold or not sold. All relational tables, of course, in a relational database, and you learn this in 330, is that all relational tables must have a primary key, and that primary key, of course, has to be unique. So if we had a house, for example, it could be maybe the it might be just an integer value that stores a different value for each different house. That is required for the relational model. You'll notice that this class house has no primary key, and that's the reason for that is that Django will automatically generate an ID field, which is what's called an auto increment or an identity field. And what that means is every time you add a new house, it will automatically add 1 to the previous column value. So 1, 2, 3, etc. Now you can override that, and you can specify your own primary key if you want to, but generally speaking, we will not do that. We will allow Django to choose the ID field for us, and that is automatically added to the table. So what role does it play? Well, this is important to understand because when you create this models.py file, this represents the schema for your database. And so you will use some of the utilities within Django using the manage.py file to create what's called a migration. A migration is actually the SQL command that allows you to either generate the tables or modify the tables if you need to. It allows web developers who, like as I mentioned to you, rarely know SQL in practice. Web developers are not SQL experts, so they don't have to know SQL. They can stay within the kind of Python world that they know, write Python code, and it will automatically generate the SQL that is necessary to do to create the databases or modify the databases. Now, one of the things that we don't really cover much in 330 is that there are a lot of variations of SQL. There's a lot of, in a sense, different dialects of SQL. Now, what that means is if you use Oracle, you may not know as well the SQL syntax that is used, for example, in SQL Server. Now, why is that important? Well, what is really cool is if your organization changes databases at some point, this means you don't even have to know the database language. You can just still use the models.py file that you created, and it will change the connection string, and it will automatically write and update the database for you using your new database. So if you shift. So it's really cool. It acts kind of as a middleware type thing where you don't have to know a lot of the database terminology or syntax or language. It's important to note that models.py is not the database. I get this. It's confusing. This is the schema. The database is going to be your db.sqlite 3 file, which is stored in your root of your project. But the models.py is the schema or metadata for your project, or for your database rather. And there's a big difference between those two. So you can think of the metadata, of course, as the data about the data. It's the column names, it's their types, it's what the primary key is, it's the relationships. That is not the database, that's the configuration of the database. So how do you generate the model? Well, once your models.py is completed, you use this manage.py utility command, and I will show you how to do this in a subsequent video, but you generate the command called manage.py, you have to put Python in front of it, manage.py make migrations. Now what that does is it generates the SQL file that is necessary to actually either create the database tables or to modify, depending on what you're doing. Then to actually execute the migrations, you say manage.py migrate, and that will actually execute the commands and commit the changes to the database. So if we did those, this would actually create the house table, and it would store it inside the db.sqlite 3 file. That will be now available in your database, and you can now store information about houses if you did this command. When you're doing any of the Python manage.py, and there's a number of utilities we're going to be using this semester that take advantage of that manage.py, you must be in the project's root folder, and I will show that to you again in a subsequent video. So why does Django do this? I've touched on a lot of this already, but one of the advantages is that if your model or your web project, for example, the actual model schema is stored with your project. Now that may seem kind of like, wouldn't it always be that way? But in practice, it actually normally is not. That Django, in effect, has the schema for your database embedded inside the project itself, which is a big advantage. If you ever need to go back and decide if it needs to be changed or what the original schema was, the schema are actually stored in the web project itself. Smaller organizations usually don't have a database person. That's usually a luxury that most organizations cannot afford. And so in this situation, your web developers, your Python coders, still don't have to really understand relational databases that much. They can still use Python, which is a big deal. And again, they don't have to learn SQL. They can just stay within their Python world. The other thing, we're going to start with a simple example, and then we'll move on to relationships. But as you talked about in 330, most databases, if not all databases, if they're of any kind of level of complexity, have multiple tables, and those tables typically have relationships between them. So in this example, we have employees and we have departments. You'll notice the convention here. Employee is singular, department is singular. That is important. Employee is capitalized, department is capitalized. That is also important. That is a convention. Column names are lowercase. In this example, we have an employee who has a primary key. That is a unique identifier for that employee, last name and first name. And then we also have a department. As you learned in 330, those two tables can have a relationship. In this situation, because of the slash, this indicates that an employee, if you start with the left here, you start with a singular, an employee can be in one and only one department, which makes sense, right? An employee can be assigned to only one department. That goes left to right. But if you go right to left, notice what it says. A department can have, and the crow's feet indicates many. A department can have many employees. Now that also makes sense. My department is accounting and MIS. We obviously have a number of faculty in our department, but I can be a member of only one department. This allows us to reduce redundancy and allows us to, in effect, specify what departments are legitimate. You can't just type in anything for an employee. You have to choose a department from the list. That choice is stored in what is called department ID, and that is a foreign key. The foreign key looks up, or in effect accesses, the department to determine which are legitimate departments. And that department ID can only take on values that are offered by the department table. So let's look at it from a data perspective. If we had, for example, an employee table, and these are the people who have been entered, and then we have a department table. The department ID foreign key, those values have to be values that are in department. You cannot choose, for example, number 5 because there is no number 5. The department ID indicates, so in this case, Lorraine Robinson, who has a department ID of 4, that indicates that she's in human resources. Ryan Andrews has a department number 3, so therefore he is in sales. And Caitlin Madison has a value of 1, so therefore she is in marketing. Notice that the IDs in both tables must be unique. Each employee has a unique identifier. Each department has a unique identifier. And because there are no 2s in here, it indicates at this point nobody works in logistics, which is just maybe happens to be the case. Also notice that the values here for department ID, which is the foreign key, they are not unique. They can repeat, which makes sense because a department can have many employees. So therefore you would expect this value of 4 and 3 to repeat because a department typically has multiple employees, and those values reflect that relationship. To model this in the Models.py file, this is what it would look like. To expand upon our our earlier example, we have last name and we have first name. That is the metadata. That is the names of the columns in our database, last name and first name in the employee table. So this is the employee table. Last name is going to be a column. First name is going to be a column. And they're both going to be char fields with a maximum length of 50. That means somebody can have a last name up to 50 characters in length and a first name up to 50 characters in length. The department table only has department name, but if you remember both of these tables, Django will automatically generate an ID for both tables, and so we don't have to specify it. Because there's a relationship between these tables, we indicate that with a department, not department ID, but department. Department will end up being an object, not an actual column name, but it will store a department object. It indicates that department is a foreign key that looks up the department. It can be empty or blank or null, indicating that an employee does not have to have a department. And generally speaking, that's what I would recommend for most of these. If you make it false, both of these false, that means you have to choose a department. It typically is a little bit more problematic. And then on delete indicates if a department is deleted, what happens to the field. If we remove, for example, let's say we remove the sales department, what happens to, let's go back up here, what happens to Ryan and Angelo? If we specify, we can specify that if sales is deleted, everything that is associated with sales is deleted. That means we would in effect terminate Ryan and I guess I'm sorry, it was Ryan and Ann that are both in sales. If we remove the sales department, if we delete the sales department from the department table, if we can specify that these two values would also be deleted. But that's probably not what we want. So instead, what we can specify is that if sales is deleted, set these to be automatically set to null, and that is they're no longer associated with a department. That probably makes more sense. Notice this is the idea of referential integrity. The relationship between these two must be maintained. If we delete sales, there is no department 3 anymore, so we've broken referential integrity unless we do something. And what we've specified is that if we delete sales, the values of 3 here for Ryan and Ann will be changed to be null values, indicating they are no longer part of a department. Now, this is also an important thing. I've noticed this with my own code. Do not copy and paste code from these PowerPoint slides directly into VS Code. I've done this a few times, and it never works out very well because it introduces special characters and it also introduces errors into your file. So I just recommend you just type this code in. Don't copy and paste. I also, again, want to emphasize that the employee table contains a department object, which acts as a foreign key. It technically is not a field, it is an object. And you will see this when we start getting into the shell a little bit more, why it is an object as opposed to a field. Okay, and this also explains the referential integrity. Final considerations is that the model syntax is extensive, and the djangoproject.com page has extensive documentation. It's really, really good documentation. By the way, Django was created by a couple of people at a newspaper, so they write very, very well. Their documentation is really good. And some of the field options, which I really like, they have, for example, email fields, which will automatically check to make sure an email address is in the correct format, including the @ symbol and all that. URL fields, which is also really cool because then, again, HTTP, and it will check the format for you automatically. And file fields, so if you want the ability to upload PDF files or things like that into your projects, you can specify that, and Django will take care of that for you as well. In addition, if you remember your database concepts in 330, in addition to foreign keys, you can also have many-to-many relationships and one-to-one relationships. We're probably not going to cover those in depth during the class this semester. We will do one-to-many relationships, but there is actually a lot of information in your textbook on that, so I encourage you to read it carefully, especially if you're really into databases like me. So I hope that helps, and that is it for now for models.